Okay, so this is the review for our Similarity and Transformations review. It's the review for the mastery test, so remember to refer back to this. This lesson was talking about similarity. When shapes are similar, they look the same, but they may not be the same size. So we say their sides are proportional. They have some type of a proportional relationship. So you'll be seeing how we use that in some of the problems. All right, the first one, which sequence of transformation proves that shape 1 is similar to shape 2? We really need to look at some of the points here and use those because we get into these scale factors of 2, scale factor of 3. And remember in the last lesson, we talked about how the points, the XY values get multiplied when we get into these scale factors. So we'll be able to see that. So just to help us out, I am going to label some of these. So this point here would be 4, -1, 6, -3, 3, -3, and let's do this vertex there too, 3, -2. And we may have to kind of go through and cross some off as we go. So let's see what happens. A 90-degree counterclockwise rotation about the origin. If I'm going counterclockwise, again, that is going to the left 90 degrees. That's going to put me over here. So that would work. And a scale factor of 2. Okay, so we'll have to check that out and see what our scale factor is here. The next one says a reflection across the x-axis, so that would flip it up here. And then a dilation by a scale factor of 3. And then this one says a reflection across the x-axis, so same thing, flip it up here, scale factor of 2 though. And then the last one is a counterclockwise, so again rotating it this way and checking that scale factor of 3. All right, so let's start with the reflections because it kind of looks like if I get the shape up here flipped, this image looks like it's kind of been flipped as a reflection, we can see. So I know it's a reflection. I want to take a look at where did these points end up then. So I get 6, 6, 12, 6, 8, 2, and 6, 4. And looking at my original, so like this one, once it's reflected, would end up here, 4, 1. And that would be like this bottom point. So once it's flipped, so I'm going from point 4, once it's reflected, it would end up here, 4, 1. And that point then becomes 8, 2. It is in that corresponding location once the shape would be reflected. And so if we notice, look at how the points to go from 4 to 8 and 1 to 2, I must have multiplied by 2. So we can definitely see that there is that scale factor of 2 going on. So we did that reflection and then the scale factor of 2. All right, next one. Which shape is similar to this shape here? Shape 1. A couple things to look at. We want it to be, so it has to look the same, be proportional, but it could possibly be a different size. It can be smaller or larger. Whenever we're talking about similar, I always like to use the example of like a mini-me. They're similar, but they can be a different shape or a different size. So on this shape, I can see it's kind of stretched out more and doesn't look the same. A is definitely not similar. B, I can see definitely looks like that shape. It looks like it would, if I were to flip this up, it would match up. However, it's just a smaller shape. So B is definitely one R that is similar. And then same here, C, the shape just does not look the same. Whether it's all right, moving on. This one here, which sequence of transformations applied to a shape or applied to shape 1 prove that shape 1 is similar to shape 2? So again, we have to go through a few, and there could be, it does say sequences, so it could be a couple of these. So let's think, a reflection across the x-axis. So that's going to flip that here. So if you can kind of picture it upside down. And then dilated by a scale factor of 1/2 or a 0.5. So that definitely looks like it would work, because going from shape 1 to shape 2, it gets smaller. So it was multiplied by that decimal. So that one works. 90-degree counterclockwise rotation, and then a scale factor of 1/2. That's going to end up here. It would also have a scale factor of 1/2, so it would still become the same shape. However, it's not going to land exactly on that shape, so it wouldn't prove that it does. Whereas this up above here, we reflected across the x, then we reflected across the y, and so by landing on the exact same shape and then following these transformations, that is the proof that we are showing that they are similar. So this one did not work. 180 degrees, that would work. That's going to get us around down into this quadrant now. So it's going to spin it around or rotate it. And then the scale factor of 1/2, that's going to work and land right on that shape there to prove that they are similar. Taking shape 1 and translating it down 2 units and 5 to the left. Well, if I just slide it down and then left, it's still upside down. It's going to be close, but it's just upside down. So the things don't match up perfectly to show or prove that it's similar. So it's just those two that actually do the proof. Let's take a look at the next one. What is the relationship between the two shapes? Well, let's see. They are, looks like it has been rotated, or even like a reflection here. So it could through a rotation or a reflection across this axis here, our y equals x axis, that they would exactly match up. And I can kind of see if I do the measurements, like this side is just about 1. This longer side is the exact same, kind of that diagonal across. So it looks like they are exactly the same. Exactly the same shapes are what we call congruent. And if they're congruent, they are also similar because they have that same shape. So we would say A here. They are similar and congruent. All right, this next one, what shapes are similar but not congruent? So which ones have the same shape, have that proportional sides, like a mini version. However, it doesn't have to be exactly the same size. So let's do some measurements here. I'm just going to use a couple sides that are easy to measure. I can tell this side here is exactly 2, using my grid as a measurement. This side is actually exactly 3. Again, I'm just using the units on the grid. And we can kind of take these other ones, kind of look at the height of it too. The height here of it is 3. So this one has that side of 2. Again, it's flipped around. The orientation is different, but if I rotated that around, we can see this side would also be 3, and the tallest is also 3. Now this one looks like it's the exact same shape. That means it's congruent. This is asking which one is not. So this one is congruent. So not the one we want. That would be similar and congruent. All right, this one looks like it is 1. Both marks are kind of in the half there, but that would be 1 unit. And then this side would be 1.5 or 1.5. And the height of it looks like it's also 1.5. And so if I'm looking at that proportion, so it looks like this side went from 2 to 1. It cut it in half. And this one went from 3 to 1.5, which is also cut in half. So we say those sides are proportional. That would be a scale factor of 1/2 or 0.5. So this one is similar, however, not congruent because it's not exactly the same. And so this would be the one we want. All right, how about this one? We got shapes 1 and 2. How are they related? Let's take a look. Again, I'm going to use the grid to kind of look at some of the measurements of the shape. This bottom is 1, that is 2, and like the tallest height, because it's just easy to use the grid. I can tell that that tall, or the height of it, is exactly 3. So this one would be a little more turned on the side if I were to stand it up straight. But this side here, it looks like it's about 1.5, 1.5. This bottom part, again, it kind of goes into the half. So that's 1/2, this is 1/2. So those ends make up 1. I got another 1 and another 1. So total of 3. And the height of it, so the sides so far look like they're I see the problem here. 1, 2, 3. Looks like the height of it is still 3. So kind of is still smushed down a little bit. It should be a little bit taller to be similar. So this one we can say is neither congruent. They're definitely not the exact same shape. And they're also not similar. So they're neither congruent nor similar. Again, we got shape 1, shape 2. The sequence of transformations applied to shape 1 that proves shape 1 is similar to shape 2 is a reflection across the, well, it looks like this shape, it gets reflected across this way. So that's going across the y-axis. And then by a dilation of scale factors, we have to figure out the scale factor on this one. How much does it get enlarged by? I can see this side here is an exact measurement of 2 units. And then this side gets larger because it is now 3 units. So what do I have to multiply by to get from 2 to 3? I can also figure that out by working backwards. 3 divided by 2 gives me 1.5 or 1.5. So that scale factor, if I take 2 and multiply it by 1.5, 1.5, that's going to get me to the sides here. So the scale factor would be 1.5 or 1.5. This one, we got another shape 1, shape 2. So what's the sequence that would map shape 1 onto? What's going to make it land and match up exactly onto shape 2? I can tell that it is some type of a rotation because it gets turned around. So it comes all the way around into this quadrant. So we got that half circle going on. That's that 180-degree rotation. I guess it doesn't matter which way you go, either clockwise or counterclockwise. Usually with 180, we say clockwise. Rotation. And then it does get larger. So let's take a look at what would be the scale factor here. So this side, that is a unit of 1. And then we get to that other top side that corresponds there once it's rotated around becomes 2. Well, how do I go from 1 to 2? Get larger, multiply by 2. So it's a scale factor of 2. And a few more here. Identify which shapes are similar to shape A and which ones are not. So here's our shape A. Again, kind of observe some things like this bottom part here is 3. It's about 2 units tall. So we can try to go and see if there's any that are identical, maybe. Like this shape up here, it looks pretty close. Let's see, we got 2, 3, doesn't look. All right, let's start with let's do this one here. Start with 3. 1, 2, 3, 4, 5, and 6. So it looks like I went from 3 to 6, it doubled. How about the height of it? Here I had a height of 2, and now it's a height of 4. And those, you can see those shapes look almost the same. It's like a mini version of it. And we can prove that it's proportional. So therefore, this shape number 3 is what we would say is similar. I can do another one with you here, like this one. Let's go to this 5. So that'd be 5. And 1, 2, 3. So this here, if I take this bottom side and the height of it, 3 to 2, kind of looking at that ratio of the sides, is 1.5. When I do that here, the longer side 5 over that height, that comes out to a different decimal there. So it's just not quite proportional to each other. So we would say shape 6 is not similar. Same with 4. This side is 2, and then 1, 2, 3. So it got kind of squished together, but taller. And so we can tell, just doesn't quite look like the same shape. Let's see here. So, well, let's do our longer side. What number is that for? Yeah, if I do that, the longer bottom side, 2, and divided by that height, 2/3 is not going to equal 1.5. That gives us more of that repeating decimal there, 0.666 repeating. So that was shape 4. Again, that's going to show that that's not similar. How about shape 1 here? Got that side is 2, and the height stayed the same, 2. Well, 2 to 2 gives me that ratio of 1. So shape 1, we can also say is over here, not similar. How about shape number 2? That bottom longer side is 3, and it looks like the height stayed 2. So these two are congruent actually, so that also makes them similar. All right, and again, this last one just looks really stretched out and tall, but let's take a look. The 1, 2, 3, and 1, 2, 3. So 3 over 3. Kind of using those sides as those measurements as a ratio gives me 1, and I needed more of that 1.5. So again, that shows me that this is not similar. Those sides are not proportional. So it was really only shape 2 and 3 that were similar. That's going through a lot. All right, one more that we can do together. If we had to pick some shapes that are similar to A. Again, I just like to kind of look at what my measurements are here because that really helps whether I rotate and end up exact same shape, or if it's going to become smaller or larger, has to be proportional to that 1 and 2. Looking at this one, it looks like it's almost the exact same shape. It would just have been rotated. So shape A would definitely be similar to that. It's similar and actually congruent. This one here, this side stayed 1, but it got a lot longer this way. So this longer side doubled, but see how that step didn't go up? That should have doubled as well. So this is a no, not similar. This side goes from 3, and then this looks like it's 1.5, 1 unit and then another half. So we can say 1.5. So if I multiply 1 by 1.5, because those are the corresponding sides, that works. 2 times 1.5 gets me to 3. So this one is also similar, has those proportional sides. Okay, and you guys can try some of the rest on your own there. All right, I hope that helps get you ready for your mastery test. We will see you on the next video.